Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this moment, I would like to explain you about the John Dalton's postulate, and we are going to specific about the atom theory. Let's see. For the first one, the postulate said that elements are composed of indivisible particles called atoms. So, for the first postulate, let's say we have something here. Let's say it is charcoal, or in bahasa Indonesia we say it with we call it with arang, okay, and then we slice the charcoal, okay, and then we slice the charcoal into uh, the smallest part we can. We slice it into the smallest thing we can, and until we reach okay, this is slice until uh, we reach into something that cannot be sliced anymore, and then it is called atom. So atom is like the tiniest part of something. And the tiniest part of arang itself, or charcoal, is called carbon. It has C symbols. So when you try to slice the charcoal into the smallest part, and then you will find something that cannot be divided anymore. It is atoms, and in this case, uh, the atom of charcoal is called carbon. So this is the concept of atom from the first postulate of John Dalton. Okay, we go to the second postulate. Okay, use second postulate about all atoms of given element have the same mass, and the mass of an atom of a given element is different from the mass of an atom of any other element. So simply, um, we know that from the previous topic, we have a lot of elements. Let's say carbon with the symbol C, and then we have, let's say, iron with the symbol is E, and then let's say oxygen, the symbol is O, and etc. And every elements has their specific. I'm sorry. Every atoms have their own mass. So let's say the atomic mass of carbon is let's say no, let's say 12, and then for the iron is, let's say, I don't know, but let's say it is 14, and then for the oxygen, let's say it is 8. So every element has their own mass. Yeah, so different element has different mass. Yeah, so it's so simple to understand. So if I have two atom here, let's say this is atom A, and then this is atom B, and then the atomic mass of A, atomic mass of A is equals to P. Then uh, the atom of A and B must be the same. Yeah, let's say it can be we can, yeah, let's say this is carbon, and then also it is carbon because the atomic mass is the same. But if we have let's say this is A, and then this is C, and atomic mass of A is not equal with is not the same with C, then we can conclude that atom A is different with atom C. Yeah. So yeah, so that's the simple things to understand. Okay, now we're going to the third postulate, number three. When elements combine to form a given compound, the atoms of one element combine with those of the other elements in a definite ratio to form molecules. And in this case, atoms are not destroyed in this process. So I will highlight in this word definite ratio. Okay, so the explanation is like this. Um, okay, compound. Okay, in bahasa Indonesia is senyawa. Yeah, so when you have atom A and then you react or replace it with uh, atom B, then you will have a compound AB. Sometimes it can be AB2 or AB3. Yeah, but we are going to discuss this later. But the concept of compound is like this: when you have first atom, let's say atom A, and then you react it with the atom B, then you will have compound AB, and you will never get atom C. Yeah, so because and you will not lose atom A. So let's say atom A plus atom B, then you also you only get compound A. Let's say it will not be happen because A B it must be always AB here. Yeah, so no atom is lost or no atom is added. Yeah. So when you have AB, then the result is must also AB. Um, okay, let's say example. Example. We know that carbon dioxide. Okay, okay. Thanks. Sorry if I get okay. Dioxide. I'm sorry if I mistype the word dioxide here. Okay. The formula of carbon dioxide is CO2. So, okay. So in this case, we have one atom of uh, one atom of C, and we have two atoms of um, of oxygen. So the definite ratio is C. So definite another definite ratio is C compared to O is 1 compared to 2. Yeah. So this ratio happens in this. Okay. Happen in this. So when you want to, let's say, I want to have CO2, then it must be you have to react uh, one atom of carbon plus two atom of of oxygen. So when you have um, so when you have, let's say this is one atom C and then plus two atom of oxygen, then you will get okay, I will use yellow. Then you will get C, and then CO2. Okay, I will bring this here. Okay, CO. Yeah. So when you have one carbon, and then you react with two atoms of oxygen, then you will have CO2. This is C, and then this is uh, O. Okay. And because this is ratio, okay, because this is ratio, so let's say in other time you react two carbon, yeah, two atoms of carbon with four atoms of oxygen. This is O, 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 and O. Then you will get two compounds of carbon dioxide. Right? So yeah, this is carbon, and then this is the, the oxygen. So you have uh, two compounds of carbon dioxide. And for this, for the first case, we have one compound of CO. And the ratio is always the same. One for for atom C, and for uh, two for atom two for oxygen atom. So when this is one, and then this is two. When this is two, this is four. When here is three, so in this part must be six, and so on. So this is the third postulate of John Dalton. Okay, and we are going to the last postulate, and I'm not going to explain you about the fifth postulate because it has been proven that this postulate is incorrect, so we are not going to discuss this. Now we can focus only for only until the fourth postulate. Okay, atoms of two or more elements may combine in different ratios to form different compounds. Okay, okay, I will add new pages here. Okay, okay, so the fourth postulate about if may combine in different ratio. Okay, may combine in different ratio. So for a carbon dioxide, okay, it consists of one atom of sorry, one atom of C plus two atoms of oxygen. But in some cases, we have also carbon monoxide. Okay, this is carbon dioxide. Yeah, dioxide because the oxygen is two, so we use term D here. The oxide, and then we have also carbon monoxide. Okay, so we have mono here because the atom here is only one. So we have, so in this case, the atom must be one atom of carbon plus one atom of oxygen. Yeah. So in this case, okay, I will write here. So this is C, C compared to O will be 1 compared to 2. It's another pen. See this in this case 2 divided by 1. And then for the carbon monoxide, the, the ratio is like this. 1 for C and 1 for O. Okay, so in nature itself, when you react carbon, the atom of carbon and atom of oxygen, the result can be not only one. It can be in several result. Sometimes you will get carbon dioxide, and sometimes you will get carbon monoxide. And it depends on the situation itself. When and different pressure of reaction condition, then the result must be different. But we are not going to discuss it now, because we will focus on the result of every reaction on the next topic. But for now, we are focusing ourselves to know about the postulate of John Dalton itself. In the fourth postulate, it said that sometimes the ratio can be different. For this case, 2.2 divided by 1, but for carbon monoxide, 1 for C and also 1 for O, not 2 and not 2 and 1, but 1 and 1. Okay, so I think that's all for this explanation about John Dalton. If you have any question, you can just type your question on the comment section below. Wassalamualaikum warahmatullahi wabarakatuh.